Alright guys, it's time for studying day 2. Feeling really anxious, honestly. Like, I just want to be done with this week already. Can't fast forward life like that though. Okay, so we went over ANOVA, which is this, right? Summary on 11 commands. Right? Yeah. This is the ANOVA for stepwise model selection. Okay, now we do model selection for best subset versus stepwise. Alright. Why do I feel like none of this is gonna be on the final? In the way that I'm studying it. I don't know. I'm just really anxious right now. But it's okay. It's honestly like, I'm just overthinking it. It's not that hard. Life is easy. Everything is easy. I know everything. I just have to apply it. Why would I know? So the best subset evaluates all possible models of each size k, best for small p predictors. Forward, backward, stepwise. Faster, good for large p-values. For example, predictors, which are over 25. So you need to know how to read output tables, which subset is best for a given k, how to choose the best model using the adjusted R-squared, CP, AIC, or BIC. Ridge and lasso regression. Hello, Bella Trijo Rosas. Welcome to the stream. Thank you for tuning in and hope you stay. Ridge shrinks coefficients but never to 0. Plot shows coefficient versus log of lambda. Let's go on to number 4. So let's just see. Okay. Let's study part 2. Excellent. Let's dive into model selection. Focusing on a subset selection, which is forward, backwards, but had intricate selection charts and tables. What are you doing? I'm studying for my regression analysis final. But I'm really anxious because I don't know how to study exactly. There was this final review that the professor went over, right? And I'm studying it using AI that can explain it for me. Thank you so much, Bella. I hope you succeed in anything that you're studying or currently working on right now as well. Because, yeah, it's making me really anxious. It's tomorrow, the final, so I can't stop thinking. Alright, so I think I know this ANOVA result table. And then for nested model selection, I know that part. And then this works out. This is good too. Alright, so here is data set ridge regression plot. Variable 14 is the categorical variable. Because none of this makes sense, but... Hello, Talha Khadim. Welcome to the stream. Thank you so much, Bella. Once again, like, Your support means a lot, and yeah. Alright, so start with the null model, intercept only. For k equals 1 to predictor, take all p choose k models with exactly k predictors, choose the one with the highest r squared or lowest RSS for that k. This makes me really anxious again. I don't know, like, any of this. Honestly, I just need to calm down and just, like, act like it's not tomorrow and just stop thinking about everything that's making me anxious right now. So the idea is to try all possible combinations of p predictors, choose the best model for each model size k, where k is equal to 1 to all the way to p, then pick the single best model using a criterion like adjusted r squared, CP, BIC. So starting with the null model, which is the intercept only, for k equals to 1 to p, fit all k, choose, okay, compare across the different k using adjusted r squared, CP, malus CP closer to k plus 1 is better, BIC lower is better, penalize complexity more than AIC over CP. Thank you so much, Bella. Hey, Primo, welcome to the stream. Thank you for tuning in. Nice to see you again. So, I'm just gonna try to do the practice example. So imagine you run regression subsets R on hitter's data and get this summary for k equals to 1 to k equals to 5. Okay, so these are the predictors: hits, walks, VR runs, putouts, add years. And then these are the r squared values, adjusted r squared values, CP, and BIC. So the question is, which is the best two predictor models? Hits plus walks. Why? Why is hits plus walks the best? Let's see. So here's the criterion. So the best subset would be slow for p is greater than 20. Huh? Oh, I'm confusing myself because what does... Wait. Okay. This makes no sense. Can you explain it simpler? Sorry, I am really confused. Okay, so you have several predictors like horsepower, weight, cylinders for predicting miles per gallon. Not all predictors are useful. Some might be useless or redundant. Model selection is picking the best set of predictors. Okay, that makes sense. Okay, so 3 ways to choose predictors. Best subset selection. Try every possible combination of predictors. For each number of predictor, 1, 2, 3, etc., find the best model, highest r squared, then pick the single best model overall using a score like adjusted r squared or BIC. So the best model is the highest r squared. Alright, so if we look back to this example, the r squared, highest is everything that adds plus adds years. Oh, is it the adjusted r squared? It's still highest over here. Wait, hold on. No. Okay, so for example, you have two predictors, A, B, and C. Forward stepwise selection. Start with no predictors, add one predictor at a time. Pick the one that helps the most. Keep adding until adding more doesn't help enough. Okay. On page 13, for best 3 predictor models, they say all possible triples of predictors. Tiny example. Okay, I think I'll learn from this example. So predict your x1 and x2. Alright, so these are the models. Which model is the best by adjusted r squared? I think it's x1 plus x2, yeah? Okay. If using forward selection starts from nothing, which predictor gets added first? X1 only. Higher r squared than 1. Well, I'm just saying x1 only if it starts from nothing, because that's what's come first. Which predictor gets added first? Okay, does this make sense now? We can try to drag down and walk through real R output to what that is. Wouldn't x1 be first anyways, since it's first on the list, and order matters with our outputs. Also, wait, I was gonna ask something else. Also, what if the r squared, or what if the r squared was lower than x2, for example? Then we would answer the second question of the example as x2. Forward selection order. In forward selection, the order does not follow the list in the data. It follows which predictor improves the model most. For example, corrected, let's change the number to test your idea. So step 1, compare x1 alone versus x2 alone. Okay, so x2 gets added first, not x1. Okay, because the r squared is higher. But this one has the highest one. Oh, okay, so you're comparing only these two. So now we have x2, try adding x1 to r squared becomes 0.65. That's an improvement of 0.05. What? Oh, okay, so if the improvement is significant enough by f-tested p-value, we add x1. So forward selection predicts, what if r squared is lower for x1? Then x2 gets added first, while by your imitation in the earlier example, I put x2 at higher r squared. So it's not about order magnitude product. So self-check, if x1 alone, r squared is 0.40, and all that, so x2, yeah, okay, that makes sense. And after adding x2, test x1 or x3 to x2. Pick the one that increases the r squared the most. So in short, order the dataset doesn't matter. Make sense? Okay, that makes sense, but let's do okay. Which is the best 2 predictor model? How? Okay, so the r squared is the best predictor model, right? But then, okay, best 2 predictor model? But there's only one. Hold on. Best 2 predictor model. There's only one model with 2 predictors, and the r squared highest value is on the lowest row. So why would it be hits and walks? Let me clarify the table example and why hits and walks is called the best 2 predictor model. So clarification, the best k predictor model for each model size k, compare all possible models with exactly k predictors. For example, we have 10 predictors total, so there are 10 choose 2, which is 45. So in my example, I only show the best one for each k, the one's got the highest r squared or lowest r, so it's not all of them. So when the table says 2 hits and walks, 2, 4, 5, all 45 outputs, the 2 predictor models. R squared always increases as you add more predictors, even useless ones. So yes, in the full table, the 4 predictor models will have the highest R squared than the 2 predictor models. But here's the catch. For k equals 2, you compare only models with 2 predictors on themselves. For k equals 4, you compare only models with 4 predictors on themselves. So this 2 predictor model is not compared to the 4 predictor models within the same k category. So me questioned R squared value of the lowest row, so why would it be hits and locks? You're right, the highest raw R squared overall would be the largest model. But the best 2 predictor model means among all models with exactly 2 predictors, which has the highest R squared, hits and locks. So, but it can't be anything else if that's the only one with 2 predictors. Isn't it, bro? You're totally right, and I think I've miscommunicated. Let me correct this. The table I gave was only showing the top models for each k, not all possible models. So in reality, for k equals 2, there are many possible 2 predictor models, like hits and runs, walks and CRMs. The table is only showing the best one among all those. But if I wrote hits and walks, and there are no other rules for k equals 2, then yes, you're right. There's only 2 predictor models listed. But, meaning if the best one, and it's simplified again, you're the only one considered. But in real output, from regression subsets in R, for each k, you see only one row, the best one, because they don't list all the bad ones. So, good catch. Okay, come back to this. Question 1. Which is the best 2 predictor models? Hits and runs. Okay, the only one. If you're using adjusted R squared, which k is best? Adjusted R squared. So, which k is best? 5? But, honestly, if you look at the jump here, let's say this is 7.7 higher. So this is 0.5 higher. So 0.2 is 0.1. This is, let's see, 7. I'd say it's 2 then, huh? Nope, it's 5. Ugh, that doesn't make sense. First one, you'd think it's this one, right? Because it has the highest R squared, but it's asking for 2 predictor models. So, like, it's asking for this. The best one would be the lowest one. That was my first way of thinking. But it's this one. Okay. And then if using BIC, which k is best? Alright, using the same logic from adjusted R squared, which now it's negative. Oh my, okay. So, which k is best? 1. There's 4. Oh, okay. So I remember he said like the best subsets, or he explained over here. I read it earlier. It said BIC lower is better. Closer to k plus 1 is better. Okay, higher adjusted R squared is better. Forward, start with intercept and predictors one at a time. Backward, start with the full model and move least useful predictors one at a time. How do we best up the output? Use the overall best using the BIC formula. BIC is n ln RSS over n plus k plus 1 ln n. Where is better? BIC penalizes model complexity more than using BIC. Okay, so lowest BIC. Okay, so if using BIC, which k is better, it has to be the 4. Okay, 4k plus 4. Using CP, which k is better? I know this one. It's CP. The best CP is k plus 1. I'm not reading the answers, by the way. So, which k is best? So, what? If you're adding 1 to k, why is the CP so large? I didn't imagine it'd be like integers. Oh my god. Lord have mercy. Okay, I think it's the lowest CP then, right? Because if you add only one to K, let's see, then it has to be number 5, right? So yes, I got one concept right. Hello, anonymous person. Welcome. Oh my gosh, y'all been yapping. Okay. Can you please explain to me what you're doing? This is for uh, regression analysis. I'm trying to answer a question, like an example that DeepSeek is showing. Um, you're going to pass tomorrow. Thank you so much, Bella. Bro, 12 people watching is better. It's the last day for finals. No, it's actually the last day before my final exam week. So, thank you, thank you. Your name is Jody? Yeah, it's my nickname. Oh. Okay, bye Bella. Bye everyone. Thank you for your support while I was studying. Oh my gosh, you guys are so sweet. So, best subject. Okay. Okay. Next example, but don't give the answers. Suppose we have a data set with 5 predictors, x1 to x5, and we run best subset selection in R. We have the following table showing the best models for each k, 1 to 5 predictors. Assume n is 100. So try to answer each. I won't give answers yet. Number 1, which is the best 1 predictor model, and was it considered best for k equals 1? There's only 1 predictor. Okay, so it has to be this one. It's k equals 1. Wait, it only says k equals 1. Why? What is the best 1 predictor model, and why is it considered the best for k equals 1? X3. So X3 for number 1, because it's the only 1 predictor. And it I have no idea. Okay, number 2. Wait, actually, or because R squared is high. Okay, number 2, which model would you choose if you use adjusted R squared as your criterion, CP as your criterion, BIC as your criterion? Okay, so is it asking for all of those combined or what? Okay, adjusted R squared has to be the highest, right? So I would say either 4 or 5. But CP has the closest. Oh, so I think it's 5 then. Yeah, because BX. Okay, 5. K equals 5. Because adjusted R squared is highest. CP is closest to K plus 1. Actually, exactly to K plus 1. And BIC is lowest. Okay, and then number 3. How many predictors are in the model selected by BIC? What? You didn't ask this before. See, this is why I'm anxious for my exam, because, like, what if they ask something that I didn't study for? Like, how do you even study for something like this? But if I'm gonna guess what this question is asking, how many predictors are in the model selected by BIC? It's like, which one is the best BIC? That is the one that is most negative, so that'd be this one. How many predictors? 3 predictors. X1, X3, and X5. Okay, and then number 4, let's see, true or false, the full model, all five predictors always have the highest R squared. I don't think he would ask that, but I would say yeah. Because, look at this R squared. This one has the highest R squared, yes. True. Okay, and number 5. If you were to use forward stepwise selection starting from an intercept-only model, and you could pick one predictor first, which one would it be based on this table? How could you get this answer wrong if it's your choice which one to choose? I choose based on the number itself. But I forgot about this forward stepwise selection. Let me see. This is cheating because I forgot. Stepwise selection forward, start with the intercept, add predictor one at a time, pick one that improves fit most, stop with no significant improvement. Oh, backwards, start with the full model, remove the least useful predictor one at a time. Combine forward and backward step. Okay, so it stops at 0.70, right? What? I forgot if you use adjusted R squared for forward stepwise selection. What did it say again? Improves fit most. But it didn't say. I'll just say 4 predictors. One predictor first. Which one would it be based on this table? Oh, man, I don't know. So this goes 1. Oh, actually, this is 2. This is 1. This goes from 6. This goes. I'd say 2 because I don't know if it's asking for best adjusted R squared or highest jump from. Wait, no, it's asking for just a predictor. Let's say x1. Jump from last predictor or what? Okay. Good attempt. Ah, no, that means I did bad. Which thing are you stuck on? I might know it. Okay, bye, Primo. So, I got all of them right except for number 5. It's x3, not x1. Best one predictor model. Okay, so I got all of them right. Except for number 5. That's the one that I was stuck on. So, forward stepwise starts with intercept only. Then adds the single best predictor that improves fit most. That's the best one predictor model, x3, not x1, because the best one predictor model is x3. X1 appears in many good models, but forward stepwise picks the single best one based on highest improvement in RSS. So, let me get this straight. The best single predictor is always the first, because I chose x3 based on the jump it had from the first K person. But starting from 0, the first, aka the intercept, that means the first predictor in line is always gonna be the best. Yes, you've hit on a key concept in forward selection. In forward stepwise, when starting from the intercept only model, you look at all possible one predictor models. Oh. This is the only one with one predictor. I forgot. We went over that. Okay. Now everyone stops talking. It's so nice that, like, people actually, like, are watching and supporting me. Man, I love streaming. I could stream every day. I mean, that is what I've been doing, but... Welcome back, Bella! Oh my gosh, I was missing you. I was like, dang, where did everybody go? Arius, oh my gosh, yes, I am back, of course, and you are back as well. I'm feeling... I started this stream feeling really anxious, because I was trying to go over everything from yesterday, where it left off. And I was, like, really confused, but now it's starting to make sense. It's like an ice block, like an iceberg. It's slowly melting. It's kind of bad for this world, but, like, yeah, we don't want high sea levels. Anyways, what am I talking about? But you were really helpful yesterday, Arius. Thank you for that. I'm still, yeah. Focusing on the review, the final review, instead of the midterms. I don't know what I was thinking, but yeah. So, the best subset versus stepwise. Full forward stepwise. Do you want to walk through a full forward stepwise simulation based on this table, or move when we're talking? Let's do one more practice problem on this, so I can be sure I got it before we're done. Great, here's another best subset selection table. This time, I'll make the differences clearer so you can practice choosing models by adjusted R-squared, CP, and BIC. Okay, so what is the best one predictor model and why? C. C. I'm gonna C because it only has one predictor. And 2, with these adjusted R-squared, which K do you choose, which predictors are in the model? So the best adjusted R-squared is definitely K equals 5. It has, with all predictors. Alright, number 3. If you use C, which K do you choose and why? The one that's lowest. Yeah. So it's 5. 5, because it's exactly K plus 1. Alright, and number 4, if you use BIC, which K do you choose and why? This one is most negative. I don't know, I'm feeling anxious. I don't know. All of a sudden, it's definitely K plus 3. Okay. Why? Because it's lowest. Alright, and then number 5, suppose you use forward stepwise selection starting from its intercept only. What is the first predictor added? Alright, let's see. I got this one now. A C. Okay. If you could choose 2 predictors, which 2 would forward stepwise actually pick based on this table, assuming it picks the best available at each step? The B would be D plus E and D. Alright. Let's see now. Don't give up. Thank you so much, Bella. I cannot thank you enough. Your support is everything. Everything that makes me less anxious and stuff. How many questions do you have left? Alright, so it's not really questions from this final review. It's more like concepts. So I'm on the 3rd concept right now. Because, let's see. He said there's 1, 2, 3, 4, 5, 6 concepts. And then I'm on number 3 right now. So I'm like halfway done. And my final is tomorrow. But so far it's making sense. Everything has made sense so far, but I'm not sure if it's gonna make this much sense on the exam when I see it. At least I'll have a good guess though. I'm not the best guesser. I really suck at guessing. Okay. So yeah, so C, because the table shows for k equals 1, C has the highest r squared among all 1 predictor models. Adjusted r squared, you want the highest adjusted r squared, and that's k equals 5. Yes, all predictors. Yep. BSC is lowest. So forward stepwise. C, 2 predictors, forward stepwise. C, this 2 is B and D. I'm not saying why is it? Okay, correction for 5B. Okay, however, the table suggests B and D is best for k equals 2, but forward stepwise starting with C might end up with CD or CD depending on data. Given the table only shows best subsets, we can't be sure, but if forward stepwise is greedy and picks best at each step, the best 2 predictor model containing C might not be B and D. For this question, if they say based on this table, the safest is to say BD is best 2 predictor model, but forward stepwise starting with C might not pick that exact pair. So from the table, the best 2 predictor model is this, yeah, but if forward stepwise picks C first, then to match the best 2 predictor model overall B and D, we'd have to drop C and pick B and D, but forward stepwise doesn't drop predictors. So likely forward stepwise with 2 predictors would pick C, and whichever improves most after C. Maybe C and D or C and D, but the tables would show that, so we can't tell for sure. So B5 is tricky. I don't think he would go through all that to ask me that. Like, he's a nice professor, so I don't know. At least I got everything else right. Okay, let's move on. But before we move on, I need to take some notes for my cheat sheet. We went over this. Why did they use this 10 choose 2 plus 45? Like, what is this for? I need to ask that. Oh, that's the adjusted r squared, isn't it? I don't think you have to compute r squared for that. Like, he'll provide a whole table with everything. But let's look at the review. Like, what is... I don't see what DeepSeek just made me go over. But can't be wrong. Model selection best subset. Okay. So lowest RSS. So let's say highest r squared is best. No, that's adjusted r squared. Highest r squared starting from intercept is always the first thing. How are you guys, by the way? Hello, Bella and Arius. Like, how are you guys? Like, do you guys have exams as well? Or... Except is always the first one. My pen is giving out. No, you don't have school? That's crazy, bro. I wish I didn't have school. That means we closed school. Oh, yeah, you're in 7th grade. Nice. School is over. That means your exams are done, huh? That is very fortunate of you. I mean, for you. Highest, just do this best. Man, all my pens are so bad right now. The lowest CP. Closest to K plus 1. Best. And then BIC best. I probably failed. Nah, I think 7th grade is something you can't really fail. Like, if you failed it, you'd have to repeat the entire course, but I don't know. Teachers wouldn't make you do that. If you actually put in effort and stuff. I remember getting report cards and being so stressed about that. But now, I don't care about the C's. Wait. Before actually, what to put on my cheat sheet for this concept? For this study concept. Try all 2P models, pick the best for size K, and choose all best using criteria. Also, like, you're really smart for, sticking around and coming back to these live streams, even when you don't have to, because your school is over. Like, you don't have to, like, study or anything, but you're watching me study and you're learning while I'm studying, so that's really good. This is a really difficult subject, so anyone who had break, like, they just watch random YouTube videos instead, so I am proud of you for that. So for K quiz 1 to 3, find model with the highest R score. Okay. Pose. Find true best model for each case. Stepwise selection. That's a lot to put on your cheat sheet, man. Well, anyways, forward, start with intercept, add predictor that improves fit most, highest f-stat, lowest p-value. Stop when no new predictors has p-value less than that. Backwards, I don't really know this stuff. Actually, you don't need to know the pros and cons. Okay, so full stepwise selection. Start with intercept, add predictor that improves fit most. Only now he's giving these formulas. I'm scared. Now let's look for stepwise here. It is give the best model for a given criteria. Computational time is not too often. The final review sheet doesn't say anything about choosing the best subset. It's so confusing, man. When you go for break, I go to school. That's true. My break starts 1 week after this. Inshallah. Can't wait. I'm gonna do so many things, man. I'm in the trenches right now. Bella, are you still here? If you are, let me know if you have school and if you need to study as well. Stepwise selection. I still don't know what to put for stepwise selection. It's kind of confusing. Start with intercept, add predictor that improves fit most. That does not make sense. Because what do you... wait, just start with intercept. That's all I know. Okay. The best subset selection provides best subset. Which one? Natural models. Computationally faster usually gives a good model. Okay. How to choose model from the table. Choose highest value tables below. Well, I just did that. Okay. CPU. Yep. Number 3. PLC. Yep. 2. Got it. So do I need to write down these key formulas? How do you find RSS though? This is so hard. And now we show the formulas and let's see now, because I don't even know how to use this. And like the final review slides don't say that. Well, I don't know. If you're beyond exam. You're right. If the slides didn't show the formulas, the probably going to ask you to compute them. It's more likely to give you an output to both we've been using and ask you to interpret the models. So let's strip the formulas and keep only what you absolutely need for the exam question. Got it. Okay. Which is the best 2 predictive models? Yes. Just really good. Okay. So adds one predictor, then adds next predictor. Okay, let's try it. Finally, moving on to number 4. Hello, Angel Ruiz. Welcome to the stream. When 1 month after this, January 8th, I go to school. Hey, that's my birthday. But we don't celebrate birthdays, bro. Actually, no, we do. Sometimes, like, we get gifts. But yeah, we don't go all out. How was your day, Angel? Do you have finals? Are you studying? If you don't, you're lucky. Unless you're jobless. You'll remember that? Nice. Good. So, next concept, ridge and lasso regression. Ridge and lasso regression. Okay, so how to interpret COVID? I'm getting anxious again, bro, because everything is new. Like, once you... Key difference, ridge shrinks coefficients, lasso shrinks coefficients. That's not a difference, though. Never to 0, can shrink to 0, variable selection. All predictors same models, some predictors drop out. Like I'm about to do with this college. University thing. Just kidding. Reading coefficients, path plots. X-axis, log lambda or negative log lambda. Large lambda equals more shrinkable, left side of plot with negative log lambda. Y-axis coefficient values. Each line is equal to one predictor's coefficient as lambda changes. I'm getting more confused as I'm reading, bro. From your PDF, when log lambda is equal to 10, then there are 19 slope estimates non-zero. Ridge keeps all 19 predictors, none exactly zero. What does that mean, though? For lasso, at the optimal lambda value, exactly 10 slopes are non-zero. Lasso selected 10. What am I reading? Quick examples. Suppose you see this output. Ridge, 15 predictors, all have non-zero coefficients. How many predictors are on the final lasso line? 7, other than we shrink to 0. Why would you... I'm crashing out, guys. Let's look at this thing. So if DeepSeek is actually explaining this correctly or not. So this is the ridge regression plot, right? Let's see. I don't make this bigger though. Okay. Oh my gosh. Okay. So, plot ridge underscore mod lambda ridge equals true. Variable is 14. Z categorical value. 7 is blues. Okay. Lead categorical variable. Negative. Notice the log. Yeah, I see it's negative log. When log is log lambda equals 10, why are they all 19 though? Okay, so this is then our 19 slope estimates non-zero. Oh, so it was 0 all this time, but when this is 10, I mean negative 10, then it becomes non-zero. Okay. These are the slopes then, huh? So, here is data set. This is so... It's making me so anxious. Lasso regression plot. I mean, he did go over this in class, but I didn't understand it then either. But it's my fault for not studying the whole semester. Calm down. Thank you. Thank you. Is Angel still here? He just said good and left. Like, there are 2 viewers though. Who's the other one? Ridge and lesser regression. Alright, but what is he trying to ask though? What is he asking though? Because this is -10, right? But I see that line starting from before that. Why is it negative? If this is just 10. Oh my god. So when log lambda equals 20 or 30? 20? Okay, 20. All slope estimates are exactly 0. Got it. When log lambda equals 5, okay, only 3 slopes are non-zero. What 3 slopes? There's only 1 slope that's not 0. Everything else is 3 slopes. Oh, okay, so if you looking closer, it's probably like this one, but 14 is league for small lambda. The slope estimated is large in absolute value. For large lambda, it shrinks to 0. Ah, so these slopes they have a large lambda. This slope has a small lambda. That's why it goes larger. Okay, that makes sense. So the lasso cross-validation plot to select the optimal lambda equation 10. Optimal lambda. Cut the optimal alpha lambda. What is cut out the optimal lambda value. Exactly 10 slopes are non-zero. What do you mean non-zero? It's like literally all above 0. Let's mean over here. Honestly, DeepSeek can't look at these PDF files. Oops. Don't look at that. Okay. Download this. Ask ChatGPT because DeepSeek is good at explaining these things, but he's not good at reading pictures. I made my remote stand. Nice. That is fantastic. Because sometimes remotes are not easy to balance. But if you can do that, you can do anything. You are literally unstoppable. I gotta study these slides for my final regression and analysis. So explain help me study and explain each concept. So I'm ready. Because DeepSeek can't see this. Yes, this is exactly what I'm here for. Let's go slide by slide and turn this into something you actually understand, not just memorize. I'll explain everything in plain language plus example explaining. Slides 3 to 4, assumptions on error terms in least square regression. Okay, we already know this. We studied that yesterday. Slide 4, ANOVA versus summary in R. Summary gives coefficient estimates, t-test for each variable, r squared, and adjusted squared. Is this variable significant given the others? Hmm? ANOVA sequential type 1 hypothesis test each variable test is adding variable improvement. Slide 5. Bruh. This is confusing me more though. Shall we take 5? Shall we take a break from studying? I do not know how to study for this. He could give like a simple study guide. But this is so obnoxious. But you know, one thing that makes me confident or like makes me happy is that I understand this section. Because this distance formula is so easy. Right? Like I got this part completely in the second midterm. Correct. But everything else is just anxious, unknown, scary, gonna fail, high probability. Because now, when I put it into ChatGPT versus DeepSeek, he's explaining it completely different. Except for the first one, that's pretty simple. But now it's like saying, like a summary. Like, should I write this down for my cheat sheet? Like, what? I don't know. Okay. Honestly, okay. Okay, let's go one concept at a time. And, let's skip the first one. Maybe. Because that's simple. What else? I want to go over the rigid lasso thing. Okay, nice. Skipping on the air something moving, I'll explain ANOVA versus summary along the way where it's out loud and some short work example. False like a slip. Which each terrain talk tells you coefficients, the b hat for each predictor, your standard areas, test statistics, and p-values. Given all other variables in the model, is this predictor significant? Different from 0. Key differences to memorize one-liners. Individual tests. Alright. Take that. I'm done. Cut the show. Cut the show. I'm done. Let's say 3:45. Wait. Alright, guys. 5-minute break over. Actually, I have 1 minute left. Actually, no, that was not 5 minutes. That was 8. But is anyone here? Let's be a little generous to ourselves. Not too much though. Oh, you're back. You're still here, Arius. Okay, well, after prayer, so take like 5 minutes though. So let's continue the break. All right, we're back, and we are going to understand every single concept there is. At least until Maghrib. Okay, so Wembu. I don't know what Wembu is, but hope you're having fun watching that. that have these stickers, but I don't know what to do with them. Like, they look really fancy, but I don't know where to put them. I put stickers on my car and my dad got mad. Because it leaves some sticker residue, which looks bad. I'm just like, why don't you just put more stickers on top? And he's like, no. Got so mad. So, man, I'm so anxious, man. Ridge and lasso regression. Actually, okay. ANOVA versus Starter. Those are cool. Thanks. But I don't know where to put them. If you have any suggestions, let me know, because I don't know where to put stickers now. I can't put on my car. And I don't really use water bottles. Except for this battery acid one. Which is... It's funny, because you're drinking battery acid, but... I'm kind of lazy to wash it all the time. So that's why I use, like, plastic water bottles. Speaking of which, I should drink some. Stay hydrated, y'all. Okay, so... some things to know. Summary LM tells you coefficients for the B hat. For there's standard errors, t-stat, and p-values. Answers given all other variables in the model is the predictor significantly different from zero. Given all other I love your cat. Thank you. His name's Yuki. He's stretching right now. You can hear him. In the model, is predictor significantly different from zero. Look at this cat pen. Let's not do ridge and lasso regression just yet. And then answer gives R and adjusted R squared. How much variation the model explains. What? And then ANOVA performs sequential type 1 tests on nested models in the order variables appear, or compares two specific nested models. Useful for deciding whether adding a variable improves model in a step by steps. So here are all the chapter slides. And I'm wondering if I should go, like, take a look at these. Best subset selection. Best I component model consists of CLBI and intercept. One component means salary equals beta 0 plus beta 1 plus epsilon bot plus epsilon. Full model with all likely variables and intercept has reduced R squared 0.575. The IC plot top row rest of the IC model consists of intercept. Okay, at the weights, blocks, CRBI, division, products. Okay, full model has BIC approximately at negative 45, 95. Okay. Best VLC approximately. Got it. Advantages of best subset selection. Simple method, very intuitive. This is very simple to understand. Now I get it after you've explained it. What? The best R squared 3 component model has to be 5.45 Okay. That makes sense. Well, I don't know what this is. What the CRBI column. CRBI. Okay, that is mostly black. Is this the code for this image? I think so. Okay, so best eye component model consists of zero and percent. What is eye component model? Or one component model? Oh, one component model means. Okay, so the one component model. CRBI and intercept. It's the intercept, right? This one has 1, 2, 3, 4, 5, 6, 7. 6, 7. This one has 1, 2, 3, 4, 5, 6. Why would it not be hits then? Oh, because best model. This one that's higher R squared. Yeah, okay. I think I get it. Okay. This question. After finding the best model for each tool, I cannot use the regular R squared to choose the optimal model because multiple R squared is guaranteed to be larger or equal for a larger range. Hello, Bella, you're back. Oh my gosh, I was literally telling Arius, like, where's Bella? Because I was asking you if you were, like, in school, if you have finals, if you have to study as well, but I think you had left the chat by then. So, yeah, welcome back. You are so smart. Don't lose hope. I'm not smart, bro. Like, I'm trying to be smart just because, like, I've failed so much already, but thank you so much, Bella. Like, Tridurosus. Oh, they're adding variable. Because this topic here is about best subset, right? And this chapter is about best subsets. Or not this one, this one. So I should be taking notes on that part over here. But then now I'm wondering, like, what about the rest of the chapters? Which one should I choose to focus on? Because there's going to be 5 or 6 concepts, right? Which concepts were they? Again. Okay, this is one concept and over for stepwise model. But subset is just stepwise. This is, what is this? Forward, backwards, stepwise. Stepwise, that's important. Shrinking methods. That's also important because we are looking at ridge and lasso regression. These shrink it and stuff, right? Shrinking, yes. Shrink methods. We need to advertise. Was that it? This is the last one? Yes. Okay. So, I don't think this is gonna be on the final. Canon. Interpret these. Best model. I know what is it? Okay. I think these chapters. And then actually not this one. Well, let's take a look. What is this thing? LOOCV. And K equals N. Yeah, that doesn't look like it'd be on the midterm. Watch it be on the midterm first thing. What is this one? Cross validation. Yeah, I don't want to study this. Wait. Yeah. Okay. I think these chapters are the ones I should focus on. Well, yeah, they're the last ones we went over after the midterm, but why do you say it's cumulative then? It's more, all these questions are based on the ones we went after the midterm. Okay, so please provide a brief support on L1 and L2 distances. Chart interpretation, selecting the best case component. I know the stepwise selection, step and achieve with model. Okay, got that, and then model selection plot. Selecting the best model based on criteria. Model selection, comparing the best subject forward, stepwise selection. Okay, this is the part that I gotta focus on that. But this is easy, so that like these two focus on. Okay. So just to jot down some notes on this chapter here. Standard linear model. This one. I was here the whole time. Thank you so much, Arius. I'm gonna be here for a long time too. Like I'm gonna study at least 8 hours altogether. I studied 2 hours yesterday, so 6 hours today. And also I already did like 1.5 hours today. But it's not about the time, it's about understanding, okay? So yeah. I barely came to this stream. Be good, do good. Inshallah, Bella. Inshallah. But yeah. Honestly, you guys are really just like really supportive, and that's exactly what I need to succeed. You guys are doing everything like I'm at a loss for words right now. I'm just really happy right now. Thank you guys. Okay, so regression setting is standard linear model. Is that so standard linear model is theta 0 plus theta 1 x1 y equals that plus 2x2 plus extra. An actual question should reach all these predictors including model. The next section. Why cannot we? Can't use R squared, regular R squared, because multiple R squared is guaranteed to be larger for the larger R's. Multiple R squared is guaranteed to be larger or equal for larger numbers. larger or equal four larger models. Okay, got it. Loops package. I don't know what that means. Just one. No, that's CB column. So that's three component model consistencies as possible. Okay. Full model, all multivariables in Oxford. This. Okay. But that doesn't have all 19 variables. Like, look at this. It's missing over here at the chum bucket. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Plus the intersect is 19, but we don't count that as a variable. Oh well. Wait, no. There's 2 here. Wait, 5 more. Oh, okay, so it does have all of them. Okay, so I'm going tricky here. Okay, some advantages. Best source of selection. Is simple method, very intuitive. And then identifies actual best match. Okay, and then the disadvantages, computation cost is too high. My pen is giving out now. Computation cost is too high. And then, in general, these are 2 key models that need to be considered. 2 key models need to be considered. And then when p is larger than 20, and slow and fast and p can't be 1. Okay. Then we're done with this concept here. Right. Okay. Individual test for each coefficient. ANOVA nested test between models. Okay. 1T is which? Okay. How ANOVA does the test verbal math? You compare 2 nested models, smaller model MO versus larger model M1, compute SSR, sum of squared regression, or SSE, sum of squared errors for each. The difference in these two tell you how much extra variation the new label explains. Format 4-1. F stat roughly reduction in SSD or degree of freedom either. And convert FP value. What? What did I just read? Lord have mercy. Verbal example you can recite. Summary: a full model might show horsepower beta hat equals to negative 0.5, 0.05, t negative 4, p is less than that. You would say, given the other variables, both horsepower and weight are significant. The negative coefficient indicate that higher value predicted lower MPG. Whoa. What is all this? Order matters. Wait, I know what order matters. Right. Wait. Next concept, please. Because I think ChatGPT is setting me up for another exam. Stop. 5:13 p.m. p.m. Oh, for Bella, you're 1 hour ahead of me. What is that time zone? Let me see. Close to California, probably like Nevada. No, that's same time zone. Probably like Utah, Arizona. I don't know. 3:13 a.m. Let me see. What time is it in? Not. That's 13 hours. What time is it in China? What can you be from? Let's see. In Australia. 17. That's too far. In Japan. 9:17. Texas. Germany. 1:17. London. Why am I doing this? I'm trying to find out. Colorado. Nice. Nice, Bella. So, you're from Colorado. Okay. What else? What else should I know about you? Because I don't know anything about your name and where you're from. But you're like one of my favorite viewers already. So, ANOVA result table, regression ANOVA. It's the most testable tables in regression. If you master this, you'll feel way more confident. I hope so. What the ANOVA table is actually doing? The answer is one big question. Does this regression model explain a significant amount of variability and why? It splits total variability in y into explain the model, leftover error. Mathematically, what? Should I read this first? Last class we talked about the disadvantages. This class we looked at the computational efficient methods for the mathematician. Forward stepwise solution. Is it computationally efficient excellent? I don't know. I don't know why I'm looking at this. Just to see if what ChatGPT is trying to teach me is part of the materials the professor wrote. So far, it looks very different. My cat is crying. 1 second. He's long. Look at this big boy. Thick boy. Yeah. Go sleep with your brother. You have a kid? Me? I don't have a kid, bro. I said cat. He left. He just came to cry. Wait. Now these formulas that ChatGPT was showing me are actually part of my material. Do I need to know these? Notice the difference between these. Oh my god. Oh, these are nasty formulas. Look at how ugh. Like, there's so many. Like, but it's not like he went over any examples of computing those formulas. He just went over the formulas. If those formulas were important, he'd have listed them in the final review. Because look, he went over these things down here for the KNN, k-nearest neighbors, this Euclidean distance. He put these formulas. So these formulas are the only ones to put down and then actually compute. I think those ones are just stressing me out for no reason. So seven is years. Okay. I think we're here. The lasso cross-validation plot. This is the part that I needed some help with. That's why I used ChatGPT. But he's really stressing me out. Like, what is all this, bro? This is nothing part of what. Let's see. I know for. You must find these. This is huge. I don't know. Like, what is all this, bro? Cute pens. Thank you. Sweet Home, Alabama. Oh, you're from Alabama. Damn. Alabama time. That's not your time zone. You are 11 hours in the future. I mean, I already knew. Alabama's not that different from my time zone. Don't want to dox yourself. Oh well. Okay, I'm not really effectively studying. Like, I'm spending a lot of time on this, but it's not effective because I'm just being confused the whole time. But let's just look at the final review itself. Like, okay. Do any of you guys have tips how to study better? Because I don't know how to use my time wisely. Let me just ask ChatGPT instead of explaining all these random other concepts to explain the ones that I already have. Can you explain this? specifically, why it starts from here, this line here. 10 slopes are non-zero. How 10 slopes are non-zero when the horizontal axis is literally -2, like, I don't know. And then, what else? What else is confusing about this? At the optimal lambda value, which is 10, exactly 10 slopes around here. What? Optimal lambda... Oh, this is the optimal lambda. Okay. Optimal lambda is what? Like, literally -2.1 or something. So, non-zero. So -1 of lambda is this. Location for optimal lambda. You have to calculate these or what? How do you... What is... Okay, let's just ask. Okay, but from what I understand, the -2 is the optimal lambda, right? And then so the slopes on the top horizontal axis are the slopes, and then so the 10 on the are the slopes, but how is it non-zero? Like, what about this is non-zero? It's literally -2 something. Wouldn't all of them be non-zero because of the mean squared error? Everything squared is positive. But let's see. What the two x-axis mean, this is the core confusion. On the last OCD plot, you always have two different axes. Bottom axis, negative log, this is just a transform version of lambda, so the plot spreads out nicely. So when you see that negative log lambda equals -2, that means this e to the -2 is that. Okay. So -2 is not 10 coefficients. It is just the location of lambda on logarithmic scale. Top x-axis, number of non-zero coefficients. Those are like 10. They represent how many slopes, betas, are not equal to 0 at their lambda. This is the model sparsity, not lambda size. So what 10 non-zero slopes actually means is that when the plot says 10 at the top, that means exactly 10 predictors have beta not equal to 0. So the fitted regression model at the lambda has 10 active variables, and all other predictors are coefficient equals 0. So that is literally the feature selection power of lasso. So let's connect this to your exact plot. You're appointed to optimal equals -2 on the top axis 10. That means the best lambda found on cross-validation produces a model with exactly 10 non-zero coefficients. The lambda is not equal to 10. While it has a slope 10. But the coefficients are still non-zero even at the best lambda. Small predictors, prediction error. So, what would be wrong to say on the exam? The optimal lambda is 10 because the top actually shows 10. What you should say on the exam? But it's not like a verbal thing. Finish the one sentence intuition. The bottom axis tells you how strong the penalty is. The top axis tells you how many variables surround the penalty. What penalty, bro? I'm not studying politics here. they are related, but they're not the same thing. If you want the next, I can explain how to compare to reach. Fake exam question. Yeah, let's do a fake exam question. If he throws in something random like penalty in there, I'm gonna crash out again. Okay, so a lasso cross-validation plot displays mean squared error versus negative log lambda. The optimal value occurs at approximately -2. At the same location, the top actually shows 10 coefficients are non-zero. Compute the numerical value of the optimal lambda. What? What? I think I might suffer like this. Okay, bye, Bella. The cats. Oh, stop sugarcoating. Tip, believe in yourself. Sugarcoating? I have to believe in myself, yes, for Bella's sake. Go ahead, answer A to D, even though he didn't explain how to compute anything. Interpret what it means that there are 10. Write one correct brief support interpretation using the model selection results. I have no idea. Honestly, I have no idea what it is. That's totally okay. Seriously, this is exactly what studying is for. You're not dumb. This stuff is abstract the first few times. Then you walk you through each part slowly, and you will understand what you just practiced. Let's do it together. So negative log lambda equals -2. You take out the negative. Lambda is e to the 2. So that's that. Okay. I guess we did go over computing that. Compute the numerical value of the optimal lambda. Wait, what section is this again? What concept? Oh, it's just the picture. What is this again? Lasso cross-validation plot to select the optimal lambda. Oh, so that's what he was computing here. Whoa. I got it. I got this. Let's see. Lasso. Cross-validation. Plot to select the optimal lambda. Okay. Oh, sorry, I woke up my cat. They so part A, let's say compute the numerical value of the optimal lambda. But how do you find the optimal lambda? Is it just this dotted line that shows that's at the optimal lambda? Of the optimal lambda value, exactly 10 slopes are on there. So e to the 2.2.2686. But how did he find that it's 2.286, bro? It's literally like a dotted line. Okay, so let's say okay, optimal lambda, let's say, for example, optimal lambda is equal to negative 2.286. 2.2286. Okay. To compute, what was it? To compute the numerical value of the optimal lambda. So, to compute the numerical value of the optimal lambda, step number 1 is to set it equal to that. Negative log lambda here equals to negative 2.2286, and you cancel the negatives, and then you take the log, or the x, you move log to the other side by taking the e, but let's say lambda now equals to e of 2.2286. And just punch that into your calculator, which is approximately what he got, which was 9.2870. 9.2870. Right? Does that make sense? Y'all? Be right back. There are 3 other people. Yeah, they're not here. They're gone. Okay, so the sun is going down. Should I end the stream and then resume after I build the cat wheel and all that jazz? I think, was this studying enough? I don't know. Okay, part B. What does 10 non-zero coefficients mean? Is the most important lasso idea in lasso regression. Some coefficients get shrunk to exactly 0. That means those predictors are removed from the model. If the plot says 10 non-zero coefficients, that means 10 predictors are being used in the model. All other predictors have coefficient 0. So the model has 10 active variables. Okay. That means, what does that mean? So, that means it has a low lambda value, right? A low lambda value. Because it's shrinking. Scary. Look at my ceiling. Okay. I think I'm gonna call it off today right now because I have to go. Bye.